Hello, everyone. Welcome to today's session, and thank you for taking time to join us today. My name is Masha, and I come from Logate, where I work in the capacity of Telco Product Marketing Manager. We would like to welcome you to our session where we invite you to discover geo-distributed network functions with real-time data using Apache Cassandra. Before we dive deeper into the technical part of the story, which is our main focus here, I would like to tell you a bit more about our companies, Logate and DataStax, who are here today. So Logate is one of the fastest growing Montenegro-based companies developing specialized solutions for telecoms and banks. And we have our headquarters in Podgorica, Montenegro. However, we also have, since last year, offices in Vienna to support our expansion through the Central and Western Europe. We have been on the market for the past 16 years, and we gather more than 80 telco, IT, and system engineers with hundreds of years of experience in the telco industry. Currently, we have our telco products in 11 countries in Europe and Middle East. And our solution is highly scalable, supporting millions of end user accounts, allowing us to work for small telecoms to tier one big telecoms that need high capacity for serving their users. About DataStax. DataStax is a leading software company created in 2011 that provides distributed data solutions. The company has a strong focus on open source development, and it is actively contributing to the Apache Cassandra and other open source projects, as well as hosting its own series of events and forums. It provides support to open source Apache Cassandra and Apache Pulsar deployments, but also and mainly a hosted version of those solutions called DataStax Astra. This year, DataStax acquired Cascada to operate a shift to machine learning and enable AI capability to real-time data pipelines. A bit of Logate and DataStax in the telco world. Our companies joined forces in 2021 when Logate did a complete refactoring of our AAA solution to support the growing demands of telecoms, and we incorporated Apache Cassandra as one of the main components of our solution. Logate and DataStax partnered up to realize the full potential of distributed database in the telco world. And one of the main requirements that Logate's product had was for the database that we use to be an open source database, which Cassandra fulfills. And thanks to its resilience and its performance, capabilities, we managed to realize some very interesting use cases in the telco industry. And that's why we are here today to tell you more about these use cases and how Cassandra can help meet the demands of the telecoms in this sphere. Now I would like to give a word to Danilo Mišević, product lead in Logate, who will tell you more about Logate's OpenProvider network functions. Here you go, Danilo.
So thank you, Masha, for this introduction, both Logate and DataStax. Good afternoon from my side also, and thank you all for being here today. So I will present Logate OpenProvider, which consists of three different network functions. So within OpenProvider, we have three different network functions: authentication, authorization, and accounting platform, subscription and authentication repository, and network data layer. So what is the role or what is the purpose of each of these network function? Each time when you want to establish a session or each time when you want to connect to internet, you will send some credentials. And the most usual way is that you will send username and password. But beside username and password, you can send your calling station ID, MSISDN, or your phone number. You can send MAC address. You can send access point name. You can send some data which are built in your SIM card. The point is that each time when you want to connect to internet, you will send some credential. And the AAA system during the authentication phase has to check the validity of credential that you sent. In order to validate those credentials, AAA has to retrieve those data from subscription and authentication repository. So when it retrieves those data, it will compare it with the one which are sent from the user, and it will say, okay, it's okay, you can have internet session, or it's not okay, you cannot have internet session. So it's the base authentication part of the function. After that, we have authorization part, where AAA will provide you the policy for the services that you pay for. And that information also AAA will receive from subscription authentication repository. In that moment, you have session with the service that you pay for. And the third function is accounting, where AAA will track the usage during that active session. So in both direction, upload and download. Regarding the subscription authentication repository, it has data about subscriber. So the time of subscriber creation, the subscriber validity, the subscriber status. It also has data about all profile that are assigned to that subscriber for each service that the subscriber pay. Subscription authentication repository also have data about the credit, for example, volume-based credit, gigabytes, terabytes, time-based credit, if you have some time-based services. It also possesses data about triplet and quintet if you have some services that demand those data. So usually both of these components should be stateless. It should not keep or contain any data, but they need the data from some previous iteration. And those data will be kept in network data layer. So when we talk about AAA system, it needs data about active session, your current active session, about previously terminated session, about policy rules, about service logs, system logs, etc. And when we talk about subscription authentication repository, it needs to store data about subscriber, all data about subscriber, about profiles for each service that he pay off, about credit, about triplet or quintet that subscriber has. And each of these three network functions is a business critical, which means if one of them is out of function, you cannot establish a session. And telecoms, of course, know it, and they have a lot of requirements or demand from each vendor that want to place system in their network. And those requirements are both for stateless and the stateful component. And when you measure those challenges for a stateless and the stateful component, you will see that they are much more demanding for a stateful component. All those requirements we can summarize in those three. The first one is efficiency scaling of stateful component. And when I say efficiency scaling, it means that when you add a new component to your stateful node, it will increase the capacity. It can process more requests. The second requirement is auto-scaling and auto-healing. And under the auto-scaling, we assume the auto-scaling in and out, so in both directions. And auto-in means that if you add a new node, you will increase the capacity of your stateful component. And auto-scaling out means that if you oversize your system initially, you can remove some node because you don't have need for that. And auto-healing means that you have some man orchestrator that can pick one stateful component and say, this component is not working, okay, we will destroy it, we will build it from the scratch, and then we will rejoin it to the cluster again. And the third requirement is distribution of the stateful node across multiple sites. And that means that you don't want to have single point of failure in terms of data. So you want that your data should be written in the multiple places, on the multiple nodes, not only within one data center, but you want to be written in the multiple nodes across the multiple data centers. And we successfully solved all these challenges under the OpenProvider project. So for the stateless component, I said it is much less challenging because stateless component doesn't keep any data. It was pretty much straightforward. And for the stateful component, we managed to solve using the Apache Cassandra. So Apache Cassandra is NoSQL cluster, which is highly available, distributed, and highly scalable. And each time when we talk about distributed data, we have a potential problem of consistency. And using Cassandra, you can configure your consistency level depending on importance of your data. So if you want to be 100% sure that you write properly data or receive the proper data, you can increase your consistency level. Also, we have a replication factor, which means that you can set number of replica of the same data within your data center, within one data center, and also you define replication factor for each data center. Okay, with all those stuff, we can say that OpenProvider as a product provide you absolute service continuity. So the product can provide you availability, which is the 5 nines or beyond. So we can summarize this introduction part as a OpenProvider is an easy scalable to meet the growing demand for different services. It allows you management of millions of subscriber accounts. Okay, let's go deeper in advantages of our solution. As Maja said at the beginning, OpenProvider is fully based on the open source. And that is the first important step. The second, we don't have a license fee. So during the installation process, we do not import some license with a precise number of transactions. And when you reach that number of transactions, all additional requests we will drop. No, it's not our approach. Our platform will handle the number of transactions or amount of transactions which can handle the hardest footprint that we have. The second stuff, we are vendor agnostic, which means that we can be integrated with a lot of different vendors. For our clients, we are integrated with more than 10 vendors. The only important thing in that integration is that all the components support the appropriate standards. And the third stuff, we are fully cloud agnostic, which means that the platform can be deployed on OpenStack, AWS, Google Cloud, Microsoft Cloud, but also can be deployed as a cloud native on the Kubernetes and various implementation of the Kubernetes like the OpenShift, for example. In terms of the distribution, we always say that we can deploy our system in the multiple data center using the Apache Cassandra. So the traditional way is to deploy it in the 2 data center, but we push it further in the 3, 4, or multiple data center. And we like to say that we can deploy our platform in N+1 data center. And the approach that we prefer is active load share concept, which means that each data center will process some amount of the traffic. On that way, we can say that we provide the maximum resiliency in the case of the outage within one data center, but also in the case of the outage, one complete data center. If you reach the maximum capacity of our system, it is really easy to extend your existing capacity by adding the new node. And by adding the new stateless component, it's very easy to extend it, but also by adding the new component within Apache Cassandra cluster, you can increase linearly capacity of your stateful component as well. And on this slide, you can see the diagram with a linear line, but there is no any data on X and Y axis. Cedric later will show you the concrete client, the concrete number of nodes, and the concrete number of transactions, and also the linear line where you will see the increasing of number of nodes linearly increase performances of your stateful component. Okay, so distribution brings you a power in terms of increasing the capacity of your system. It also provides you resilience in a case of outage of one complete data center. And on this slide, we have concrete implementation for Croatia Telecom, one of our clients, where we deployed our system in 3 different data centers. And each of them is active, which means that we push our component and our product on the edge, very close to the customer, and we decrease the time of the session establishing. Each of these data centers has 3 stateful components, so cluster of 3, and the replication factor is a 3, which means that each data will be written in each node of 3 data center. As you can see, nodes within one data center create ring structure. So if you cut the path between 2 nodes, it doesn't mean that you lose complete data center because there is another path for communication to other nodes. So it is within one data center, and we have one big ring which connect all nodes across all data center. So if you cut the path between 2 data center, it doesn't mean that you lose communication between 2 data center because there is another path for the communication. Okay, OpenProvider is a one convergent solution for all access technologies. And when we say all access technologies, I mean Wi-Fi, both public and professional, voice over Wi-Fi, DSL and fiber, 3G, 4G, and 5G. And it is a multi-tenant solution, which means that each access technology you can implement within one tenant. But also, it allows you to implement two, for example, access technology in the same tenant if you have a need of correlation of data of the two different access technologies. In order to make it more simple, new service creating, we developed the service management engine. And this service management engine is a main processing engine within the OpenProvider product. It consists of 4 different stages, and each stage invoke one open function. An open function and service management engine together is our low-code concept. So the basic idea is that with the using of service management engine and the open function, you can create very complex service, very complex policy rules with a really basic programming knowledge. So you don't need your development team or your OM team, operation maintenance team, the professional programmer. If you have a basic knowledge of programming, you can create very complex policy to support you in providing a very complex services. Open functions bring you a protocol in built-in protocol functions for a radius, for a diameter, for LDAP, for a DHCP, for a SOAP, REST, HTTP2, etc. Okay, so in next 3 slides, I will summarize all the features of our AAA solution. So our AAA solution is a fully 3GPP compliant. It supports all AAA protocols, radius, diameter, LWD, SOAP, REST, HTTP2. It can be deployed in the multiple data center. So it's fully geo-redundant solution, put it on the edge. We support horizontal scaling, a linear increase of the performances by adding the new node. We bring the service management engine and the open function, so the low-code concept, which allow you to create the complex services with the basic programming knowledge. We provide real-time policy and charging control through push-up mechanism that controls service activation, deactivation during the same session. As I said, we support scaling in both direction and auto-healing. The part of the solution is AUSF for a 5G. OpenProvider is one solution, as I said, for all access technology, and one of them is a Wi-Fi, which is very specific. So Wi-Fi brings you some special demand in terms of protocol like AAP, protected app, AAP over TLS, AAP SIM, AAP backup. All those protocols we support. AAA for a fixed, which is a traditional. AAA for a fixed and a mobile converge FMC service, which combine throughput from the fixed and the mobile internet in one logical throughput. Different variation of the password encryption, LWD interface for a communication with the common database, and HSS, radius packet of disconnect and change of authorization. So if something is changed in your profile or in policy during the active session, our system can detect that change and then set packet of disconnection and change of authorization in order to disconnect the current session and create another one which support the changes that are made in the middle time. We support 3GPP AAA diameter protocols for voice over Wi-Fi. Our system can be also DHCP for IPv4 and IPv6 addresses. So OpenProvider can assign to the end user IPv4 and IPv3 addresses. And all those stuff, I think we cover all possible functionalities for the AAA component. Okay, what is the network data layer and what is the difference over the traditional approach? So the traditional approach is the monolith architecture of the system. And that means that each network function, we have its own database. So the number of network function is equal a number of the databases. And it demands much more resources because you have a lot of databases. And you have certain limitation in terms of interconnection or integration of the data between the different network functions. On the right side, we see the network data layer, which is one step in disaggregation. So the network data layer should support the storage for each of the network functions. On this slide, we have two network functions which are part of the OpenProvider, but the network data layer can support all other network functions which are defined according to standard. And for network data layer implementation, we also use Apache Cassandra. So network data layer brings you all the advantages that Apache Cassandra has. So it is highly scalable, it is distributed, geo-redundant, it can be easily scaled. The idea is that all other network functions would be completely stateless, and the only stateful component within your setup will be the network data layer. And our network data layer support both structure and the structured data. Structured data, where you have precise structure with the precise number of the field and a precise description of each of them, and unstructured data, like a session, for example, where you have the precise definition of several fields, but all other fields can be dynamically created in a case that you need it. Also, our network data layers support the TM Forum APIs for some third-party integration to the billing system, to the monitoring system, etc. So in terms of the NDL, we are fully deployment agnostic, which means that our network data layer should be implemented in a way that the two data centers are on the premise, on a client, and the third data center can be somewhere in the cloud. Our advice is to put in the free data center, because in that case you can afford yourself to lose one data center and still to have enough capacity to process all incoming requests and have redundancy. And the idea is that each network function will ask network data layer within the data center. But it's not mandatory. In the case of the lost network data layer within one data center, you can switch to network data layer in the other data center, because replication factor will be set in a way that all data are replicated across all data centers. And I think it's a really good stuff to have at least free data center or multiple data center, because from our experience, now telecoms perform the regular upgrade really frequently. So we have regular upgrade once in 6 months or once in the year. And I think it's really good and really beneficial that you can offload complete site to redirect your traffic to another two site, to perform the upgrade. And the moment when you are 100% sure that everything is okay, then bring your data center again in your cluster. So that's it that I prepared for you. Now Cedric will present you in more detail Apache Cassandra and DataStax.
Thank you. Thank you, Danilo. Thank you. So Danilo did a few strong statements. So now I need to be good, right? Because you say that Cassandra is low latency, geographically distributed, absolute continuity of service, self-healing. So now I would like you to dig with me with how the database works and really understand what you can do, what you can achieve with that technology. I'm Cedric Lundven. I'm leading the developer advocacy team at DataStax. Developer advocate because the company is really committed into bringing awareness on that open source technology. So Cassandra, NoSQL distributed database created by Facebook 2008 because they cannot scale anymore with the existing relational database. Distributed by design. You can install the system on a single machine, single node, container, pod, just an archive to unzip. And you can achieve about 2 to 4 terabytes of capacity and 3 to 5,000 transactions per second and per core. Distributed, you want to install the system on multiple machines. And they will communicate to each other with the peer-to-peer protocol gossiping. There, first you need to realize there is no master. It's not a master-slave architecture. All the nodes are the same. You will read and write for every node the same. The nodes are then grouped as here, this circle, big circle you see on screen, and it's called a data center or a ring. So it's a NoSQL database, but you will save your data as table. In a table, you will have some primary key to ensure the unicity of the record. That's no different from relational. But you will also have something called a partition key. And the data will be distributed across your nodes based on the value of this partition key. You store together what you want to retrieve together. And you will shape your table in a way that in your where clause, in your filter, you always provide the value of the partition key. Because then you access the single node, get the data very, very fast. The query is not distributed, it's super fast. So there, it's super easy to add column. It's almost free to add column. So this is why we also shifted to machine learning and AI use cases. Okay. To scale with the database, I don't know how many times you say scale, Danilo, but to scale with Cassandra, you want to add nodes. How many nodes can you add? Well, we were lucky because last year at ApacheCon, Apple testified about the usage of Cassandra. And as you can see on screen, the numbers are pretty big, like 300,000 nodes and multiple petabytes of data online. It's not an analytical database. Here we are talking about read and write in real time, single millisecond response time, even with that volume online. Another example we like to take, same conference, different speakers. So here Netflix, 22,000 nodes. Okay, not so big, right? But you know, still quite a few data. 12 petabytes online again. 900 cluster. And here you see that line that the benchmark processed by Netflix. The more node you add, you can achieve linear scalability. So the more volume, the more throughput you have, the more Cassandra would make sense because it will overperform almost everything. Because at some point, if you are not masterless, you can, you know, the more nodes you add, you will not get the performance you expect. Okay, NoSQL distributed. I show you on just before one data center. Of course, in a Cassandra cluster, you can have multiple data centers. Again, you can read and write from every node, and the data will be replicated for you. This is your choice to say how many times you want your customer to wait. Do I want my consistency on my local data center close to my user, or global that you to change? Also, when you save some data there, you can choose that data needs to live only on this data center for regulation reasons, for instance, for confidentiality, security. Or you want that data to be available everywhere. And if it's everywhere, the idea is, of course, to reduce the latency between you and your customer. It's kind of, sometimes it can be called an edge database because the data is very as close as possible to your user and you interact as low latencies. So now, if you think about data is distributed, there is no master. And if on top of this, I told you that the same data is available on multiple nodes, well, you should realize that then you can lose any of the nodes and the system is still active. So the RPO, RTO concept have no sense. It's active, active, active everywhere. And you can shut down the node just to do some maintenance, whatever. And you bring back your node online and the node will catch up the transaction that it have missed. That's part of the protocol. It's called intent handoff. You can lose a node, you can lose a couple of nodes, you can even lose the whole region because the drivers are clever enough to do the load balancing between cross data center. So what you'll see is, of course, a spike in the latency if the application needs to switch, but that's it. The service is still available. So you can install your node on multiple geography. It's so easy to install. You can have the same nodes on Azure, AWS, GCP. Where now to get a single data layer available across the clouds. And sometimes you are using multiple services or multiple cloud providers, for the price or for the functionalities. And now you can share the same data set. And the replication is done by the database. You don't have anything to do except this inter-cloud connectivity, which is not the simplest. I will not lie, but technically speaking, once the network is in place, Cassandra and the nodes can see each other. The replication is done for you. Apache Cassandra. Apache is very important here. It's the community that will protect the license. It's free, it's open source, and it will not change anytime soon. Some databases have to change their license model to protect themselves against the cloud providers that were selling the technology without contributing back to the community, of course. So here, Apache protect the name. And this is why you cannot see Apache services in Cloud Vendor. They had to play and tweak and rename. And I have heard about Spaces or CosmoDB, which are not exactly Cassandra, but they cannot reuse the name because it's protected. So in a nutshell, this is how you can present Cassandra to man in the street. High availability, linear scalability, low latency, global distribution. And on top of that, you can add security. All the communication are encrypted, data locality, and overall performance. Everything is optimized to have very, very fast first writes and also reads. And so my last slide for you today is Cassandra is used a lot, but because it's free, not everybody is aware. But here are just a few customers of DataStax that are using Cassandra in the use case that you can see here. Logistic assessment management, personalization. But anytime you have high throughput, fast writes, time series data that fit this table model, Cassandra could make sense. Thank you. And now I will hand over to Masha.
Thank you, Cedric. And thank you, Danilo, for this in-depth overview of the solution. And now, finally, I would like to present our last guest, our speaker, who unfortunately could not be here today in person, but he will be here on video. His name is Amir Salem, and he comes from Croatian Telecom, part of Deutsche Telekom Group, where our solution has been implemented. And he will tell you more about the specific success story that we have had here, and how the implementation of our AAA solution powered by Cassandra has changed the way they do business in this core network part.
Hello everyone, my name is Amir Salem. I'm working in Croatian Telecom, that is a part of Deutsche Telekom Group, currently as Broadband Core Platform and Services Department. And in this next few minutes, I would like to share with you our success story about implementation of OpenProvider AAA solution from Logate to our company. At the beginning, I just wanted to say a couple of words about motivation. So, motivation for change from our side was basically, first of all, end of line for our equipment, and we also have had capacity lag on our fixed and mobile AAA services. Also, we wanted to ensure future capacity requirements and new functionalities and feature, and at the end, we wanted uniform telco cloud infrastructures. So, with that mentioned, what was our situation before? So before we had only 2 locations, and we used to use physical servers for our AAA system. We had 3 of them. 2 was in one side, and the third one was on other side. Also, today we have the same situation with our AAA database. So some issues with the old AAA environment was that they were working in active-passive mode, and they reach capacity limits. And because we used to use physical equipment, it was a little bit challenging for us to just increase capacity. And also, like mentioned before, our hardware and software was coming to end of support. So some key drivers for change is that we wanted the whole new AAA solution or AAA modernization, And we wanted to ensure better resilience, better redundancy, and also cloudification and, like mentioned before, capacity requirements and functionalities. With all that mentioned, we decided to go with Logate's OpenProvider AAA solution, and today we can say proudly that we are using this system more than 3 years. And with this system, with this solution, we gained a lot of benefits. Some of technical benefits that we gain is in resilience improvement, because we implemented this solution on our 3 sites, and all 3 sites are active and working parallel. So today we have active, active, active mode. Also, we virtualized this solution via Red Hat OpenStack, and with that we gained some horizontal scaling for capacity. And we improved our system performance KPIs. For example, today we have better response, better time duration. For example, authorization process, and we improved monitoring system, because with OpenProvider today we are able to monitor a lot more KPIs that we couldn't do before with our old solution. But not only technical benefits were gained with this solution, we also gained some business benefits, because with this solution we were able to implement some new services, for example, mini broadband service or a Cisco umbrella service, where all the logic is implemented on AAA side. Also, we did data lake integration via Kafka, and today we can proactively monitor customer lines, and we can proactively react if we see some problems. We can react before customer reaches to us, and with that we also gain some benefits in customer experience. At the end, I just wanted to mention a new project that we are currently working with Logate, and that is modernization of our AAA database. So, like mentioned on the beginning of this presentation, our database is currently facing the same challenges that we had with our AAA system. It is only 2 locations: active, passive mode, physical equipment, end-of-life software and hardware. And because of that, we decided to go with central database Cassandra. Project started 1 month ago, and yeah, we are really looking forward to go deeper to this project. So yeah, that was the short version of our success story of using AAA OpenProvider AAA system. Thank you very much for your attention, and best of luck to all.
Okay, thank you very much once again in the name of our whole team for being here.
Thank you.